Hey everybody, welcome to the first tutorial of this semester's multimedia production class. The image in the background here is one of the amazing little houses that can be found all over Barbados. This is just across from the beach in Bridgetown, capital of Barbados. These tutorials are going to be a really important part of class, and so I want you to get started on the right foot with these. In order to do the tutorials well, you need to not just watch them, but do them. So you need to have Max downloaded or whatever software we're working on, have it installed in your computer, ready to go, and then do the things that I'm doing in the tutorial along with me in the software, pausing and rewinding as much as you need to. So it's not just a case of sort of watching this and sort of getting a rough idea. The stuff that's in these tutorials is the stuff that I expect you to have down cold by the time you arrive in the next class so that we can move forward. If you're not 100% with this stuff, I need you to actually stop the tutorial and send me an email. And I don't care if it's Wednesday night or Friday night or Sunday night or Tuesday night that you send me the email. I will endeavor to get back to you and answer your questions as quickly as possible, but it's really crucial that you do not come to the next class without having thoroughly understood and practiced everything that's in the tutorials. And as I mentioned in class, we're going to be moving more and more towards a model where class time will be devoted to discussion and screening of works and critique, and the technical material will all be relegated to the tutorials rather than covering it sort of once in class and again in the tutorial. So these are going to be a very important part of the class. Just as one final note before I get started, remember that everything I show in the tutorial is a demonstration. I don't want you to, more than the few times necessary to learn it, I don't want you to do it the same way I did it. I'm giving you tools, and then I want you to use those tools creatively in your own way, differently than the way I use them. So varying, understanding things well enough to create variations is a very, very important part of what we're doing here. You need to, first off, go to the cycling74.com website and download Max if you've not done so already, and make sure Max is installed and running on your computer before you continue on with the tutorial. I'm using Command Tab because I'm on a Mac to switch to Max, and then Command N to create a new Max Patcher. And first things I do when I create a new Max Patcher, I crank up the zoom here to 200%. I like to start working big. Eventually the patch gets crowded and you have to shrink it down, but start working big, particularly because you're beginners. Kids' toys are big and they don't have a lot of details. They're easy to get your hands on. Think of yourselves as kids with regard to this. You're new to it. So zoom way in and make the objects big and easy to manipulate. Don't work with these tiny little details on the screen. The other thing I always do is I click the Format button here, which is a little paint bucket, and I click the P, the P with a diamond around it here, which changes the settings for the whole patcher. And I switch to a fixed width font. My favorite is Monaco. And that way, when I create a new object, I'm immediately in a fixed width font, which allows spaces to show up very clearly. So you want to do that right away. So we started out with learning the floating point number box, which we create using an F. And one of the things I mentioned in class is there's always at least 3 ways to do things in any computer environment. So I can hit the letter F. If I don't remember that, I can also go up here and select the floating point number box from this menu, and it makes one for me. And if I don't remember that, I can always type the letter N, which creates a new object, and type the object flonum, which also creates a floating point number box. Now here, I taught you this right off the bat because it's very important. Resizing objects is often something you want to do right away because the power of the floating point number box is gone if you're using it in a small format like this. Let's lock the patcher with the lock and take a look. Yeah, it's a floating point number box, but I can only change the integer component of it. So when I make a new floating point number box, I can change the integer component of it, but only up to 2 decimal places. In our work in class, we're often going to need more than 2 decimal places. So you want to stretch that box out, and you see the further I click and drag to the right, the more detail I can change with. The further I click and drag to the left, the coarser my changes is. And actually, if I click and drag to the left of the decimal point, I'm actually creating integers here. We very briefly also looked that there is an integer number box where there's no fractional or floating point component to the number. We can create that using I, or we can create it from the number menu, or we can create it by typing the word number into an object box. Always 3 ways to do things. We didn't look at it in very much detail, but the integer number box only handles the integer portion of the number. So if I send it 33.690000, it cuts off the 0.69 and just gives me a 33. So if I pass the number through the integer number box back into a floating point number box, the floating point component is gone. This is going to become useful to you later on. The integer number box also functions as a number processor to remove the floating point component of a number. We'll set that aside for now. I'm going to cut it and paste it and move it. And just quickly review what we looked at with the floating point number box. So we can use it to enter numbers. We can also set the number that it displays by sending it a message. I create a message box with the letter M. Also can create a message box here with that button. Also can use the letter N to create a new object and type message. 3 ways to do it. So you see that's a theme. Always 3 ways to do things. So let's say the number 5. If I send the number 5 to my floating point number box, which I do by connecting it, then locking the patcher, and then clicking the message, that message is sent down this patch cord to the floating point number box, and it's displayed there. It is also, importantly, passed through the floating point number box to the next object it encounters. So again, if I lock the patch, which I did this time by command clicking in the gray space, I click the message 5, it will send this 5 down the patch cord to the floating point number box, display it, pass it further down, and replace this 32. And this is going to keep going as long as I want. This 5 is just going to propagate down through each one of these objects so that they're all set to 5, and every one of them passes that 5 along to the next object. Note, however, that if I take a message box and say put an 11 in it, and then put a floating point number box below it, and I'm duplicating here, by the way, by holding down the Option key and clicking and dragging the object. So if I send the message 5 to the message 11 and then to a floating point number box, take a look at what happens. The 5 does not replace the 11. In fact, the 5 gets turned into an impulse. We call it in Max a bang, and it simply sends the 11, and the 11 is now passed down through all of the number boxes that we connect. So if I click the 5 triggers the 11. It sort of virtually presses that button, and then the 11 is the value that's going to propagate down through all of our floating point number boxes. So instead of doing that, there's a separate object that sends that impulse, that bang, and that is the button, which we create with the letter B. Also, we can create it here with the button menu. Also, we can hit N, type button, and it makes a button. 3 ways to do it. So that button will virtually press this button, which contains a message, and send that message. So let's change the message to 44.3. When I click the button, it clicks this button, which then sends 44.3 through the first number box, which then passes to the second, to the third, etc. So what we did in class was a little exercise, which is very typical of what we're going to do all semester. Having just learned the basics of these few objects, what implications are there to it? And what questions are raised in your mind? And for the moment, we're going to ignore the right inlet of the message box. We're going to ignore the right outlet of the floating point number box. Just working with what we have, what implications and what questions are there? This is where I'm going to ask you to make variations based on the things you feel are implied and the questions you have about the objects. Like, hey, I wonder if a single button can be connected to multiple message boxes. I'm going to hold down the Shift key and show you that you can actually make multiple connections with fewer clicks by holding down the Shift key while you're connecting. And then if you have one of these that you don't know what to do with, you can command click in the blank space and it'll delete that cord. I'm using Option, click and drag to duplicate these boxes. And you can test your theory. Okay, this button is now connected to 4 message boxes. Each one of them is connected to their own number box. Will it send all 4? Click. Yes, it did. You know, theory proven. Great, let's try out another theory. What if I have a different button that only sends 2 messages? To this one and that one. Is that going to work? Can I click this and have these 2 values be set? I can. But can I click this and have these 4 values be set? Yes. Ah, interesting. Right? So this is the process that you guys are going to go through. This is just me doing it, but what I'm doing is I'm modeling the kind of experimentation that I'm going to assign to you and want you to do. Now, we stopped doing this after a while because the message boxes and the number boxes and the buttons are kind of abstract just on their own, and we went to something more practical. So that's what I'm going to do right now. I'd like you to go back to this this message box and number box exercise, but we'll do it later when we have a little bit more information. I'm going to delete all of this work, and I'm going to go back to that email that I sent you, which had this bit of code in it. And take that code, copy it, and paste it into my patch. And this is what I sent to you. And as I mentioned, we're not going to talk about the auto patter and the patter storage objects yet. I just want them there for you because they're very handy and we're going to use them a lot over the course of the semester, even though they're rather advanced objects. But here, even in this setup that I sent you, I've got 2 message boxes which have the messages store1 and store2 in them. And I've got a floating point number box, which we recognize. I've also got a new object, which is a toggle. That's an on-off switch. And then I've got this object, jit.world, and I've named my world John, and given it the attribute @floating space 1. So this is just squished, but if you laid it all out, there's spaces between these things. jit.world space John space @floating 1. So the reason why this John and this storage are in all caps is because that's a convention in the class where when I want you to know that you can change a value to whatever you want, I'll put it in all capital letters. It's an arbitrary value. So I called it John. I could have called it Fred. And now, if you see here, my window into my world, and in fact my world itself, is called Fred. Now I'll call it big underscore world. What I can't do is I can't put a space in here because spaces separate the, these are called arguments. Spaces separate the arguments to objects. So jit.world, space, something new. What's the name of the world? Big world. Space, some attribute. Which attribute? Floating. Space, what are we setting the floating attribute to? 1. And what that means, the floating attribute, it just means that this window here, the world window, won't hide behind other windows. Without it, here, let's just get rid of floating 1 for a second. I'll show you. My window's still there. And when I click here, oh, that window falls behind. See, it's back there, but it fell behind. And you lose your work very quickly that way, particularly in the beginning. So I just gave you the at floating 1 attribute so that your window into your world is always floating on top. And also, we have to turn the world on. So we lock the patch, click the toggle, now our world is active, it's on. So the next thing we did is we created a jit.gl.camera. So we placed a camera into our virtual world. And as I mentioned in class, that camera is created 2 meters from the center of the world, looking at the center of the world. We can change all of those things later, but that's the default location. And then we created an object in our world. We created the jit.gl.gridshape object, which creates a sphere for us. But since we're not rendering it in 3D right now, it looks like a circle. But it's a very rough-edged circle, and we're too close to it. So the next thing we did is we flew out using the jit.anim.drive object. And this is the first time that we really are connecting 2 nodes together. We're connecting the jit.anim.drive node, which is a node that animates things, to the jit.gl.camera, which is a thing in our world. It's a camera. It's in fact a camera that's showing us this image. And then we're going to use a message box, and this is a very, very typical formula. So become familiar with this because we're going to use this over and over. We're sending a message to an object, and that object then manipulates another object. And we're going to send it the move to message and give it an XYZ coordinate location to move to. So we'll keep it at 0, 0, X, and Y, meaning we'll keep it centered, but we're going to move it away from the center of our world. We're going to move it to 10 meters from the center of our world. And the third argument is speed. We'll have it move there over 1 second. So move to space X space Y space Z space time to move there. We can think of it as speed. And what I like to do then is squish my box to make it easier to read. So now it's a move to, where are we moving to, how fast are we moving there? Lock my patch. I did that using command click in the blank space. Click, and my camera backs up. It flies away from the space. Flies away from the center of the world, the center of the space. And so there's my circle. And it's kind of rough-edged. So the next thing we did is we took this jit.gl.gridshape and we gave it a higher resolution using the dim attribute, and we gave it dim 100 by 100. And now we have a much smoother edged circle. Why does that change it? Well, let's take a look at something for a second. I'm going to go to the, which one do I want to go to here? I'm going to go to the, poly mode, and just make this wireframe for a minute and remove this dimension 100 by 100, and we can see that our circle is made out of relatively few polygons. Let me zoom back in on it. I'm going to use move to 0, 0, 2. Go back to that starting position. Relatively few polygons, and so the edges of the circle itself are flat. It's not actually very circular. So if I crank this up using @dim, which is short for dimensions, 100 by 100, and go back to poly mode 1, you can see the mesh of my circle is much denser, has much more detail, and so the edges of the circle are nice and smooth. So that's why we're adding that dim 100, 100. Let me fly my camera back out and get out of that poly mode so we have a nice matte circle. And we created another circle and positioned it 2 meters to the left of our original circle. And there it is. And we created a third circle and positioned it 2 meters to the right. So now we have 3 circles. Lovely. And what we discovered, I'm going to put these in the order they are on the screen. And we did this in class. This is my left one, my center one, my right one. And you can see which is which. If I delete it, it goes away. Command Z to undo. Delete this one, it's the middle one, it goes away. Command Z to undo, it comes back. We tried to use the same node to do the same activity. So I'm going to use the jit.anim.drive node to change the location, not of the camera, but of one of my grid shapes. Using the same message, move to. And where do we want to move this to? We'll move it up. So right now it's at -2, 0, 0. And we'll move it to -2, -2, 0. That's going to move it up 2 meters from its current position. Let's see if that works. No, that moves it down 2 meters. Whoops. -2, 2. Yes. +2 is going to move it up. There we go. -2, 2, 0. And if we want to move it somewhere else, we can add an additional move to. We can move it 1 meter further to the left and 1 meter further up. And indeed, there it goes. And we can take it back to its original position. Great. And these messages become buttons, and that's very handy. It's also eventually limiting, and we're going to see better ways to control things. But initially, it's a very handy way to do something. When you want your objects to do something, you just make a button that does that, and as soon as your patch is locked, the button works. Very few environments are that quick to create an interactive control, which is one of the things that's really powerful about Macs. So the next thing we looked at was changing the color of these objects. And we learned about the attrui object, A-T-T-R-U-I, which we can create like that and then connect to our object. We can also, there's a little yellow circle with a triangle in it on the center of the left of objects. And when we click it, we can go to attributes and select the one that we want to inspect, which in this case is going to be color. And it creates the color attribute for me and automatically connects it. Whereas if I type in and create the attribute, the attribute object, I have to select color from the menu, but you get to the same place. And the reason it's called GL_color is because if we put it in a message, the message wouldn't be color, it would be GL_color. And then red, green, blue, alpha. So with a message to our object, we'd have to use GL_color to change the color. But that's not quite how we did it in class, because I wanted to show you sort of a next level of thinking. And that involved talking a little bit about color theory. So the first thing we did in color theory is kind of looked at what color theory we use on the computer. And we use the RGB color theory, meaning every pixel, every dot on the screen has a redness, a greenness, and a blueness. And the absence of red, green, and blue is black. The presence of red, green, and blue is white. And every other color can be made through some combination of red, green, and blue. And you should experiment with this a lot, because knowing this color system applies to anything you're going to do in the digital media. This is the color system of light and of computers. If you're a painter, this is not helpful to you. If you're working in the print media, this is not necessarily helpful to you. But for computers and for lighting, they use the same color system. So whether you're gaffing, or whether you're doing studio lighting or theater lighting, or whether you're doing digital media of any type, the RGB color theory is going to explain how colors mix and how they interact. So you'll get a lot of practice with that this semester. So what we did is we learned another object called PAK, P-A-K. And this sticks numbers together. Because ordinarily, when we create a floating point number box, we're only interacting with one number here. But color, we learned, is just made of three numbers, a redness, a greenness, and a blueness. So PAK allows us to stick those numbers together. And they are floating point numbers. We're going to pack three floating point numbers together, and then we're actually going to also pack a 1 on the end, because that number is transparency. And for right now, we're not dealing with transparency. We're just creating an opaque color. But later on in the class, we'll deal with transparency. And we can pack those and send them right into the attrui. And that gives us individual controls of redness, greenness, and blueness. The other thing we did was we set something about this floating point number box using the inspector. We went to the inspector, and here at the bottom, we set the minimum value of this number box to 0, the maximum value of this number box to 1, because our colors are represented by a minimum of 0 and a maximum of 1. It doesn't make any sense to have red higher than 1. It doesn't make any sense to have a negative value for red. Red is either absent or totally present, or some value in between. So since we've made a change to this particular number box, we definitely want to duplicate this one. I did that using Command D, which is a handy duplicate feature. And I made 3 number boxes, one for my redness, one for my greenness, and one for my blueness, which now allows me to, with very, very high fidelity, select between 16 million or so different colors for my circle. So it looks like about 3 decimal places worth of information is useful there. And by highlighting this whole structure, copying it and pasting it, I can certainly apply that to the color of my other circles as well. And then we looked at randomization. So we were talking about the ways in which we could let the computer decide the colors of these circles, which is a really, really, cool possibility. And we talked about the fact that it can be random, which, interestingly, as one of the students pointed out, and I think it's a great point, we use, in common speech, we speak of random as something that human beings do when acting spontaneously. Oh, that was so random that he did that. But actually, bizarrely, and this often happens in language, that's the opposite of the true meaning of random. The true meaning of random is determined by some unpredictable outside cause. So flipping a coin is random. Picking a card from a deck of cards is random. Rolling dice is random. And anything a human being does is actually not random. Anything a human being does is somehow based on our experience, our emotions, our understanding of the world, our history. And so it's fundamentally non-random. It might seem random, but actually, unless it was determined by a coin toss or a roll of the dice, it's not random. So interestingly, computers also cannot be random in the same way that human beings cannot be random, but computers can fake it extremely well. And so we have an object called random, which we call a pseudo-random number generator. It's faking randomness pretty well. And we're going to create a random 101, which is going to give us 101 different possible values. I'm going to use B to create a button. I'm going to hook a button up to my random generator, and then I'll make a number box so I can see what comes out. And again, this is a very common structure. Button triggers an object to do something, and the result comes out the bottom. So every time I click this, I'm going to get a randomly chosen number. And the reason I put 101 in here is because I want random values between 0 and 100. That's actually 101 values, if you think about it, right? Because the numbers 1 through 100, that's 100 values. But if I want to include 0, that's actually 101 different values. So random 101 is going to give me values between 0 and 100. Now, why do I want 100 different values? Because I don't have a random generator that's going to give me random numbers between 0 and 1. That's just not part of Max. So I'm generating random numbers between 0 and 100, and then I'm just going to do some math. Divided by 100, floating point. Very important, put that decimal point there. Now, I've got random numbers between 0 and 1. 0.69, 0.89, 0.93. Why does that work? Well, let's think it through for a second. I'm generating random numbers between 0 and 100. So my lowest possible number is a 0. My highest possible number is a 100. I'm dividing those numbers by 100 and seeing the answer. If I divide 0 by 100, I get 0. If I divide 100 by 100, I get 1. And if I take any other value that lies in between, like 50, 50 divided by 100 is 0.5. 33 divided by 100 is 0.33. So any number this random is going to spit out is going to result in a value between 0 and 1. And it just so happens our colors need a value between 0 and 1. So the happiness is tremendous. And also, you see what I did here? This is one of the nice things about computing. Computers are just big calculators. That's all they are. All they do is crunch numbers. From when you turn them on till you turn them off, they only think in numbers. So for people who are math challenged, like me, as I mentioned, I had severe problems with math as a kid. Just couldn't get it. When I found the computer, it was a revelation, because the computer does all the math for you. You just don't ever have to do a calculation. You just instruct the computer to do the calculation, and it's done. And so in the multimedia field, where calculation is very important, it's good to leverage the computer as a supercalculator, so that you don't have to do nasty math, and you don't even have to do simple math. The computer does it. So our random number generator divided by 100 gives us a value, and let's see if we can just randomize the redness of the center circle. Okay, it's a little hard to see because there's color in the other, so I'm going to zero out the other colors and just randomize the redness. It's going to give me dark red, almost black, bright red, slightly less bright red, almost black, bright red again. Okay, it's working. It seems like it's working. So let's take this same process and apply it to greenness and blueness and see if the computer can generate totally random colors from its entire palette for us. We got a green, we have a dark green, we have a dark orange, purple, green again. Great, seems to be working. Wonderful. So we can take this whole process that we've just made for one circle and apply it to the next circle. Now notice our screen's already getting a little messy. There's a couple things we can do about that. One command that I like is Command J, which just shrinks all objects down to their minimum necessary size. And then also, I really like squishing objects. These randoms can all be squished like that, and it makes it even clearer, the separation between the word and the value. So you spend a lot of time sort of doing house cleaning and maintenance in node-based multimedia environments because they get messy. They just get messy. So now I have a button to randomize my center circle and a button to randomize my right circle, and everything works in concert. So I still have a button over here that moves my left circle, and it still works. And if I want to take that structure and add it to one of my other circles, it's going to work too. Everything's going to work in combination. When you add one thing, it doesn't interfere with the functionality of something else, which is a really nice aspect of node-based multimedia. And in code-based multimedia, you get into trouble a lot. You often add a new thing and it interferes with the function of an old thing in kind of an unexpected way. It happens sometimes in node-based media as well, but it's nowhere near as common. So let's take a look at where we want this right sphere to move to. We'll just have it do the same thing. It can go up and it can go down, and it can have a random color. And this can have a random color as well. All right, so here then is the assignment that I want to give you based on all of this. As I said, I want you to explore, I want you to learn this. We need to learn this. But the next step, the important step, is to explore the implications of this and to use the tool to sort of answer the questions in your own head. So, for instance, I'm going to give you an example of the kind of thinking I want you to do when you take this homework assignment on. Because what I'm going to ask you to do is make variations of what we've done in class. And through those variations, explore things that are implied and explore questions that you have about the object. And make discoveries. I mean, that's a very important part of this, is to make discoveries. I mean, I know lots of stuff about this, and I can teach you lots of stuff about it, but it's just going to be, the earlier you can start teaching yourself stuff based on what I've taught you, the better off you are. You're going to be able to proceed much, much faster. So, if I was given the assignment, make 5 variations on this based on what's implied by what you've learned and what your questions are, I would be like, okay, all right, so, can I use one of these random generators to change the color of all 3 circles at the same time? So I'm going to actually delete the red randomizer from my right circle, and I'm going to try to use the left circle's red randomizer to control the redness of its buddy on the right. And actually, I'm going to get rid of this circle for right now. I only need 2 circles in the world right now. I'm just going to deal with 2 circles. So here what I have is the redness of both circles should be controlled by this button. In fact, I can make a separate button and put it here and just say the redness of both circles is going to be controlled by this button. And I can set the other values to 0 and just see if it's working. Okay. Both circles are changing redness together. That's great. But what if I add some other colors to this? That's interesting. The redness of both circles is changing, but the green and the blueness of both circles is remaining fixed. Okay, that's interesting. So I'm going to call that experiment 1. I can use one randomizer here to change the color of 2 different circles. What if I want to use 3 randomizers to change just the redness of 3 different circles? I'm going to get rid of this whole structure to make a little space, and I'm going to disconnect the green and the blue connections. And notice you can move a patch cord by clicking on the green handle or clicking on the red handle at the bottom. And I'm going to bring back my other shape that I just deleted. And, right, so I've still got 3 randoms, but instead of randomizing 3 different colors, I'm just randomizing the redness of all 3 spheres. And it seems to be working, except for, look at my right one. My right one still has some other colors stuck in it. So how could I get rid of them? Okay, and that leads me right to the next experiment, right to the next thing I can try, right? Okay, I wonder if I can use a message box to send a 0 to the greenness and the blueness of that right one. Let's see. Yes. Right? Idea, question, theory, test, and then a response. Now I have 3 random rednesses. Nice, great variation on the patch, right? It's doing something totally different using the same set of ideas and using the objects differently than the way I showed them. That is exactly how you're going to show your understanding. Let me give you one more, sort of for those of you who are feeling comfortable with this and want to reach a little bit further. Let's look at one more possibility here. Okay, if pack sticks things together, and right now I'm sticking together 3 floating point values and a 1, I wonder if I can create a move to message using pack. Experiment. Might not work. Gonna try it. Pack. The first thing has to be the word move to. Then my X, my Y, my Z, and I'll just make my speed 1. Oh, okay, so it makes a pack. This pack had 1, 2, 3, 4 inlets because I had 4 things. This pack has 1, 2, 3, 4, 5 inlets because I have 5 things. Let's hook it up to the drive and let's try something. I'll put a message of 3 into the second inlet, because the first inlet is actually this word move to, second inlet is the X position. Let's see if it does it. Whoa, it does it. All right, let's try to put something like, let's put a -1 into the Y. Aha, so now I've got something really interesting. I can make buttons to move these all over the place. Move it up, move it down. Aha. And, I can use the random. I could use random to move it to a random location. So, if I did random 6, for instance, that would give me values between 0 and 5. So let's move it to a random X and Y between 0 and 5. See if that works. Oh, I'm going to put some numbers here too, just to see my values. Okay, it moved somewhere. It moved somewhere else. seems to be working. I'm going to zoom out my camera a little bit more here. There's my camera. Move my camera to 15 meters away. Now I have a random movement generator. So you see, again, that's a great example of the kind of thing I want you to come up with in your homework, which is taking the same set of ideas and using them in a different way. Now, granted, this is a stretch. I think not many of you would come up with that particular experiment. But there's lots of other experiments you can try, and this is going to be a very important factor in your learning. So that's it. That goes through all the material we covered, and it kind of gives you a sense of my expectations on the homework. And that is the homework. What I want you to do is create 5 variations using the material that we covered that differs from the way in which I used it in the tutorial and shows your personal exploration of the media. I hope this has been useful for you, and as I said, please make sure that you email me with any questions you have, any questions on this material before the next class meeting, because not only do you need to have all of this, what we've covered, pretty well down by the time you get to class, but I'm going to want to move further. So, your understanding of it needs to not be sort of cursory, but pretty deep. Thanks for your attention, and I will see you next week.